All right, we're going to review how we wrote equations of tangent lines, starting with the tangent line for the circle. So most of us did follow the hint, but I do love that this person actually did use calculus. The issue, though, is when you have not solved for y, you're using implicit differentiation. So the derivative of each term, and you're saying with respect to a specific variable. So 2x is good, but it wouldn't stay 2y, it'd be 2y dy dx, so that you are putting it back in terms of x, since the derivative of y squared, being 2y, is with respect to y. So now that everything's back with respect to x, you can solve and reduce. So that's the derivative everywhere. Then you can say the derivative specifically at 3, 4 is negative x over y, which is the same exact answer as if you had taken this slope, which is rise over run, and so its perpendicular slope is opposite reciprocal. So I do appreciate the calculus there. Here, we were writing the equation of a cubic with certain roots, so I saw this person did it, and the tangent eyeballed to be nice, so I was trying to figure out why it was wrong. Well, that's because this person didn't make the problem go through -1, 3. So to get it to go through -1, 3, you're going to obviously use that A trick. Really, the parameter of finding A is plugging in x and y temporarily. So we get that it's -1/2. So basically now, I look at the second person here and I see, well, theirs looks tangent. Why isn't that right? And they went through -1, 3, but then I realized they didn't make it cubic. They made it quartic. So they added an extra root there. The correct answer would be to take this equation and I FOIL that out. So it's usually x squared minus 2x, minus 3x, and then plus 2. So I'm multiplying it all by the x right away. So now, this equation is actually down here at the bottom that I hand drew. So if I want to know what the tangent line is to, I'm going to have to find the derivative. I'm going to leave the -1/2 out front and just do the derivative of the rest. Now, we're not figuring out when the derivative equals 0. Those would give us some nasty answers, somewhere between 0 and 1, and somewhere between 1 and 2. And I would use the quadratic formula, likely, to find those values. I'm trying to find the slope at specifically 2. So I'm going to find the slope, the derivative, at 2, 0. All right, so when you plug in a 2, I did not do this yet. Plug in a 2. It looks like your slope should be -1, and I do believe that's what people with accurate answers were using. Do not forget to always embrace point-slope form. Y minus y1 equals m times x minus x1 to put your answer in that form. What was it? Oh, well, being it was going through 2, 0, you can clean this up even if you choose to. Okay? Now here, this person, when we did the rational function question, excuse me, this person made an extra asymptote. We only had 2 asymptotes. So we're going to write the equation with exactly those asymptotes from the directions. And now it's a matter of finding the tangent line. So how are you going to find the derivative? Are you going to find the derivative by quotient rule? I would not, because the derivative top is 0. I would prefer I go back and write the equation another way. So now I can take the derivative, and the derivative of the inside, of course, is 1, so I don't really need chain rule. And so once I have my derivative, I am looking for the derivative, at 5? So I plug a 5 in there. So again, I could even switch this notation. It means the same thing. And the derivative at 5 looks like it's -1. Okay, and then of course point-slope form would help you there. And I think one more I want to talk about, of course, is this cosine curve. So this almost looks tangent, but not really. You can see it's kind of going through it. It's not kissing the graph. So really, to find the derivative of this equation, once of course you got to this point, I mean, even getting to this point, you're saying that the period 2 pi over b is given by pi in this problem. So when you solve for b, you get 2. So that's the coefficient of the x. The amplitude is how far from the center of the graph you went. So it does look like you went 4 up and 4 down. And it does look like the center, of course, is at 3. So now that we have everything, we're going to take the derivative of this. Now, the 4 is already there. The chain rule is going to tell me to leave a 2 on the outside. And the derivative of cosine is negative sine of the original. And I already just took the derivative of that original. And the derivative of 3 is 0. So this derivative looks like it's negative 8 sine of 2x. So this person, I believe, has the correct answer. You can see that the tangent line really does look more like just a single touch rather than going through. So now we're going to find the derivative, I guess you can even write it this way too, at 3 pi over 4, 3. All right, just trying to write it different ways for you. So when you put in 3 pi over 4, remember that reduces, and then we have, 3 pi over 2, and the sign is negative 1 there. So the final answer there is 8. So that is the slope. So what I like is how we're just using y equals mx plus b form with the ordered pair, and you're all done. So good job for your efforts on using all that calculus.